Siyanamukela kwi-Ithala Education Platform ibambisene ne-Go Digital SA Foundation. Siyathemba nizolijabulela lolu hlelo.
Sanibonani grade 12 Mr. Mbailo sothatha for physical sciences. Namhlanje sikhuluma nge-Doppler Effect, ifola under wave, sound and light. Doppler Effect usually kuba question 6, right? It's a short topic, ungakwazi ukuhlanganisa khona ama-marks akhona cause sometimes 12 marks, 13 marks, got up closer to 10% of the paper. So mawuthola ama-marks, ama-mark ngala so kungakusiza ke nakho, right? Doppler Effect, right? Njengoba idila nama wave city, wave, sound and light. Yini Doppler Effect by definition and yenzeka to makunjani. So the first thing sikhumbula ukuthi masikhuluma nge-wave yini fanele sikhumbule ukuthi i-wave ina into sibiza ngama-wave equations. I-wave equations will be uthi the speed of the wave is equal to the frequency of the wave times the wavelength, right? Futhi siyazi ukuthi a frequency is 1 over a period. Noma ngathi period is 1 over a frequency in the total length, right? Then siyazi ukuthi the speed of a wave uyakwazi uyi-calculator by taking the distance divided by the time, the total distance of the wave. So again, kumele ukhumbule nje one thing in terms of graphs before size sikhulume nge-Doppler effect on its own. Mawukuthi une graph emi kanje, right? I think it's it, right? So uzobona ukuthi this graph here gives me what? 2 full waves. Give me what? 2 full waves, right? Nala it also gives me what? 2 full waves. Mawuzogcina la kuzothi 1.5. Mangiyaqhubeka kuzoba 2.5. Let's say ngithi ngala. That's so that is 2.5. Now into efana uyigade ukuthi khonani kuma y-axis. So into ngiyaziyo ukuthi ngikasuka la ngizikhona le distance isuka from this point to this point, noma from this point to this point. A distance between the 2 consecutive points that are in phase, right? To any point nami ngasuka la ize la, right? Nala same thing, so I can look at this distance here. It can be this distance, no, it can be this distance, any distance that separate the 2 consecutive points that are in phase. Now that distance mawubuka ngokwe-graph umele wazi ukuthi imeleni kahle kahle ngoba kwi-graph sidoba as a distance, but what could be the meaning? Fanele uqaphele ama-graph in terms of what is on the x-axis. Yabo kule graph for example mawukuthi sino delta t la kuthiwa in second, kanti ngala basinika bani i-distance, right? Mhlambe kuthiwa in meters or in millimeters. Lokhu ke sekwenza umehluko baphakathi kwalama graph awu2, because le distance besikhuluma ngayo it does not mean the same thing here iphinde isho the same thing ngala, right? Lana njengoba sikhuluma nge-delta t, le distance le representa isikhathi sokuthi kube kuhlangane bane one full wave. So that is the time to cover a full wave. It's the time. Leo time leo sibiza ngani nge-period. Actually, distance between 2 points that are in phase, 2 consecutive points that are in phase, sibiza ngani nge-period. Why sibiza nge-period? Ngoba kuma x-axis kuno delta t. So into sinayo ngala represent isikhathi. So isikhathi ucover a full wave usibiza ngani? Sisibiza ngani nge-period. So iyo period igele, right? Kodwa mesiza ngala u-x-axis une distance, kusho ukuthi kusuka ngala usize fike la to cover 1 point. Siyabuka ukuthi this one give us what? The length of a wave. Lokhu le distance ibiza ngani nge-wavelength, right? So kumele ukhumbule ke lokhu. This one is the wavelength while this one is the period. So before ukwazi ukuthi usebenzisane ngempela information uzoyithola uthola kanjani, then you'll have to use this graphs and check ukuthi delta t lona ngala this distance kusho ukuthi the full wavelength length is if it's covered it will be the wavelength. Here if it's covered that will be the period, right? Then yabo simawuthola uT uyakwazi ukuthi umhlanganisa kule speed kule formula ezothi f is equal to 1 over t. Senga calculate bani i-frequency ngoba sengiyazi i-period, right? Kodwa uyakuthi i-graph banginikeze in delta t, so ngakwazi ucalculate i-period. Lana ke ngiyathola bani i-wavelength, so again ngasebenzisa le graph ngize la kule formula ngithole bani i-frequency, right? My focus with frequency kakhulu ngoba ngiyazi ukuthi ku Doppler effect so sebenzisani i-frequency. But again from this point uzobona ukuthi speed of the wave in a medium does not change unless ukuthi kunama physical properties of the medium that have changed, noma ihlambe temperature. Otherwise masokhuluma the speed of a particular wave in water, right, it will be the same. Kungashintsha i-frequency kushintshe ne-wavelength kodwa speed sakhona that will remain the same. Noma so the speed of a particular wave in air, right, mhlambe sothi u20 meters, it remains 20 meters. So uyabona ke from this formula ukuthi masothi uv is equal to f times lambda, mase sothi ukuthi uv remains constant in a medium. Uv uyashintsha makuthi uyashintsha medium, mhlambe the wave was moving in air manje si yahamba bani through water, then suyashintsha medium nalo v uzoshintsha. Kodwa ke makuthi is the same medium kungashintsha i-frequency then kushintshe ne-wavelength. So into uzobona ukuthi for us to maintain uv constant makunyuka i-frequency kumele kwenze njani, kwehle i-wavelength, noma makwehla i-frequency kumele kunyuke i-wavelength ukuze si-maintain uv constant. So in that case sobona ukuthi u-frequency i-frequency ne-wavelength they are inversely proportional. So if frequency increases, wavelength decreases, and vice versa. If the wavelength increases, the frequency will decrease. So kumele ukhumbule ke lokho. Higher frequency, we have a shorter wavelength, right? Or longer wavelength, lower frequencies. Those are the few things we follow ukhumbule from grade 10. Venenza ama-waves ka grade 10. Now, asikhulumeke nge-Doppler effect. Your Doppler effect happens when there is an apparent change in the detected frequency due to the relative motion between the source of the sound and the listener. Doppler effect idila kakhulukazi nani ne sound. Now, a sound is a longitudinal wave. If it's a longitudinal wave, it's a pressure wave. Idinga medium ukuze ihambe, that propagate. So that is a sound. So when you deal with sound wave, most Doppler effect, we'll see ukuthi as the sound is a longitudinal wave, noma sibiza ngani nge-pressure wave. So uyakwazi futhi kuyisebenzisa makuthi udinga calculator frequency noma udinga calculate wavelength. The same formula siwabize ngama wave equations are still applicable even with sound, right? Now, Doppler effect yenzeka mawukuthi a person omuntu olalelayo mhlambe umi nje emgwaqweni khona i-ambulance iza ngakuwena, yomenza ngakuwena uzwa ngathi i-sound iya increase, ngathi umsindo we-ambulance, right, uyanyuka wona uya increase. Then makuthi umsindo uya increase, does really increase is the speed or frequency ngempela iya increase in of the siren or the sound that is produced noma emitted by the ambulance. Uzobona ukuthi udriver uhleli lapho ku-ambulance kuwayena nje the sound is the same, la lizosuka khona azafike la yakhona nje the sound is the same, i-frequency is the same. Kodwa umuntu omuzwayo esombiza nge-observer noma sothi i-listener, right, lo muntu uzwa ngathi makusondela i-ambulance uzwa ngathi i-sound ngathi iya-increase, makuthi i-ambulance ihamba kude nayo uzwa ngathi iya-decrease. But in reality i-sound wave did not increase in frequency, right? Ile nto soyibiza ngani nge-Doppler effect. Kako sithi i-Doppler effect is the apparent ngoba vele akushinji. So it is the apparent change in the frequency of sound, right? So loku kuzokunika 1 mark. Already talking about apparent change, especially that the change in frequency, buga ama keyword, the change in frequency, right? That is very important. Kumele ukulume ke change in frequency. Hii inenza kube nale change, right? It's the apparent change in frequency of sound due to isizathu sokuthi kube khona naleyo change due to the relative motion kusho ukuthi omunye uyamove relative to the other one, the relative motion between the source of the sound and the listener. That's okay, Doppler effect. So the first thing is apparent change in frequency. Now the second part is because of this relative motion between the source of the sound and the listener, right? That is Doppler effect. Kumele we understand before we bhale phansi ukuthi what does it actually mean. The frequency ayishinji kwayona, right? The frequency does not change, right? But the person who's receiving noma recorder leyo frequency uzwa ngathi sengathi iyashinja, but in reality ayishinji ngoba u-driver hlambe we-ambulance kwayena aka-move relative to i-siren. Hlambe i-siren bayibeka phezu kwemoto, right? Bese kuyahamba njengoba kunyakaza konke kwa-driver nemoto ne-siren, they move at the same speed, same direction, yonke into. Kusho ukuthi u-driver is not moving relative to the siren, right? Kusho ukuthi yena there is no relative motion, ingakho kwayena i-sound ayishinjanga. But the person who's outside the vehicle uzwa njengoba imoto iza ngakuyena vele you can see that it's approaching. Kusho ukuthi there is a change in distance between the car and the person. Change in distance kusho ukuthi kune displacement. It means one moves relative to the other one. Makushinja vele distance between two objects, uyasho ukuthi this object they are moving relative to each other, right? So u-driver akezwa lutho kusho ukuthi njengoba lena there is no change in distance between i-siren no driver, kusho ukuthi there is no relative motion. If there is no relative motion, then there is no Doppler effect. Now what creates a change? Ngoba soba nokuthi let's say we have a source of the sound emile nje hlambe nanti hlambe speaker sila so nas producer i-sound wave enje, right? So into simona ukuthi this can be considered ama wavelength. About i-wavelength ngala wavelength kuyalingana everywhere, right? That is the now njengoba i-stationary uyabona ukuthi mawukuthi hlambe khona umuntu omile la uzwa exactly if i-wave in a wavelength efana nalo kusho ukuthi i-frequency ngala ifana ne-frequency ka-listener. So to fs, that's a frequency of the source. This is the source of the sound. Mic or whatever we are using here, hlambe a speaker, right? That is the source of the sound. It's not the sound, right? Then you have the sound that is produced. So zobona ke ukuthi i-wavelength produced by this by this speaker is the same wavelength that will be detected by this person, right? Angithi siyakhumbula ukuthi a sound wave, it's a pressure wave. Let's say now this person here, this speaker, right, or the person carrying the speaker wenze njani uyanyakaza, is moving, but the person here is stationary yena akanyakazi. Now yabona ukuthi by the time lo usondela ngala njengoba kuyi pressure wave kulokuthi lama wave la ezangala enze njani ayacompresseka angithi uyabona ukuthi as it's moving this way ayacompresseka athi I pressure wave. Ucompresseka kwama wave kwenza njani kwenza ukuthi I wavelength yenze njani I decrease. Kanti sithe earlier on ukuthi I wavelength ne frequency they are inversely proportional to each other. Njengoba compresseka kanje kusho ukuthi kuncipha ini I wavelength. Makuncipha I wavelength kwenzekalani I frequency iya increase. Kodwa la I sound wave still producing the same wave yona ayishinjanga kusayikona. The problem is that into yenzekala in between, right? Ngoba ama particles la in the air, they are the one that are being compressed ngoba lo usondela kulo muntu. That is the relative motion. Yabokuthi by the time kunganyakazi these two, the source of the sound and the listener, there is no Doppler effect. If frequency low zoizwa ifana exactly ne frequency izothola lo muntu. But by the time this one start moving toward this one, we compress ama wave in between the source of the sound and the listener. To compress then means u decrease I wavelength. Can you decrease I wavelength kuya inyusa any a frequency. That is the apparent change. Lo muntu lo uzonotice sengathi kuyashinja ke I frequency ya le sound iya increase. Right? So uthola bani I frequency enkulu kune frequency ye sound. Right? So in the first state yabona ukuthi I frequency of this the source of the sound is equal to the frequency of the listener. Ngoba there is no relative motion. Lana sibona ukuthi the frequency of the source of the sound did not change. Kusawu Fs. Kodwa ke sibona ukuthi izoba incane kune frequency of the listener ngoba listener uzwa ama compressed waves. So frequency of the source, the sound is less than the frequency of the listener. Kusho ukuthi frequency of the listener is greater than the frequency of the source of the sound. Right. What will happen if this sound is moving away? Angithi uyabona lana is toward the person. Siyathola ukuthi the frequency of the listener is greater than the frequency of the sound. What if lo muntu njengoba ehleli ngala, now this sound wave, this sound ahambe in opposite direction. Yawumehamba in opposite direction kuzowenzekalani kulama wave. Lama wave azo stretcheka. Ma stretcheka a create bani a longer wavelength. Ama longer wavelength lead to lower frequencies. So yabona ukuthi I wavelength manje yenze njani iya increase. Maku increase I wavelength, I frequency yenze njani iya decrease. So uzobona ukuthi the frequency of the source in that case is now greater than the frequency that the listener detects. Right? Frequency of this is now greater than the frequency of the listener. Loku kwenzeka if the source of the sound is now moving away from the person. Right? So we have that one. Right? So into singayichaza sothi we have two possibilities. Three possibilities. No relative motion. When there is no relative motion, the frequency of the listener iyalingana the frequency of the sound that is being produced. Right? Makune motion. When there is relative motion, with relative motion, we have two possibilities. With relative motion, the frequency of the listener is not equal to the frequency of the sound or the source of the sound. Then, makuna relative motion, there are two possibilities. Kungenza ukuthi they move toward, so kungaba a listener moving toward the sound, noma kungaba a sound moving toward the listener. So into uzo understand ukuthi at this point So consider ukuthi okodwa kuphela okumovayo, right? So it can be either the listener who's moving toward the source, or the source of sound is moving toward the listener. One of them will be stationary, right? Ngokwe exam guidelines so sebenzisa ukuthi one is stationary. Kungaba i-listener, makuthi listener is stationary kusho ukuthi kunyakaza abani i-source of the sound. Noma makuthi source of the sound is stationary kusho ukuthi kuzonyakaza i-listener. The example ukuthi if someone is standing on the road across the road, uzothola ukuthi that one is standing or stationary, uyi-listener. Then kuthiwa imoto iyezake, i-ambulance noma i-police car, angikuyabona kuyona, that is the source of the sound coming toward the listener. And the other one kungaba ukuthi when the listener moves toward the source of the sound. Example ingaba hlambe i-siren noma insimbi esikoleni. Because uyazi ukuthi makhala insimbi vele ayinyakazi yona. So if wena uzo insimbi esikoleni mase uyahamba uyagijima ngoba hlambe ulate, when you are the listener, you are moving toward the source of the sound. So sithola ukuthi if it's moving toward, the frequency of the listener is greater than the frequency of the source. Kusho ukuthi the listener hears a frequency that is greater than the frequency that is produced by the source, by the sound. Then sibe nani ngokuthi they move away, right? When it's moving away, we have the same possibility. Kungaba i source of the sound moving away from the listener, noma kungaba i listener moving away from the source of the sound. And in that case, solukuthi the frequency of the listener will be less than the frequency of the source. Kusho ukuthi i listener izozwa i sound ene frequency encane kune frequency of the sound itself. Right. What else kumele sikhulume ngayo ke la? Sasithi thina ukuthi the listener stationary noma kungaba ukuthi uyahamba naye uyanyakaza, depend. Kusho ukuthi singathola i-speed se listener ngoba sithi relative motion. Masikhuluma nge-motion vele sikhuluma nge-change in position. So sikhuluma nge-speed. Then sizokuthi u-VL sombiza ngani? Speed of the listener. Right? Speed of the listener. So makuthi u-stationary, then u-VL uzoba u-0. Makuthi uyanyakaza, then it won't be 0. Right? Mese sikhuluma ngani? The speed of the source of the sound. Mese kuba ne speed of the sound. Those are two things. Speed of the source of the sound. Ngesikhathi niga le information, le example, this is the source of the speaker is the source of the sound. It's not the sound. So makunyagaza is the source of the sound that is moving. It's not the wave value. It's moving as long as it is produced. The wave has its own speed. Ingahambisani nokuthi the source of the sound is moving or not. The speaker here is moving. That is the source of the sound, but it's not the sound. Yona producer any wave, wave nayo in a speed sack in that particular medium. So singathi ukuthi kunono Vs, this will be the speed of the source of the sound. The source of the sound. Now, as masoti source of the sound, sikhuluma ngale ambulance. Ambulance, it's not the sound produced. Ambulance hamba ne speed sakhona. It's not a wave, right? Masikhuluma nge police car. Noma sokhuluma nge isikole asinyakazi angithi. So if velocity yakhe u0, it's not the sound. Mase kuba uv, that is the speed of sound. Speed of sound. Into engahlangeni nala. Right, speed of sound wave. Now sikhuluma ngama waving, the speed of the sound wave. But this was just a speed of a person, of a listener. This was a speed of the source of the sound. That can be a car, can be anything that produces a sound and can move. Speed of the sound. So into simona kusesina ma quantities bangaki awu 5. Khona lo frequency of the listener, sine frequency of the sound. A frequency of the sound, akusiyona a frequency of the source of the sound. Kumele sihlukanise lapho. Then we also have OVL, the speed of the listener, OVS, the speed of the source of the sound. Mrs. OV, that is the speed of the sound wave, right? So masibafaga all together sithola le equation, a Doppler effect equation ezothi mofuna ukuthola if speed or frequency of the listener, look at the speed of the sound plus or minus the speed of the listener over the speed of the sound wave plus or minus the speed of the source mezothi times the speed of the sound, right? So uzobona ukuthi ma analyze le equation uzobona ukuthi ma ukuthi uVL awunyakazi u0 nalo Vs na mhlambe i-source of the sound is not moving, so kusho ukuthi mangi replace ngizothi uFL uV plus or minus 0 V plus or minus 0 lana ngisho by the time ukuthi there is no relative motion times bani times Fs, V over V 1, right? So at the end so thola ukuthi FL is equal to Fs kuza lapho when they are moving. Then when the source of the sound and the listener, they are not moving, then the frequency of the listener is olingana and the frequency of the sound, right? But when we have moving toward each other, right? Let's say the speed, the object or the source of the sound is moving toward the listener. Kusho listener u0, then the object is moving toward it. Sithe ukuthi the frequency of the listener izoba inkulu kune frequency of the source of the sound if they are moving toward. Mathematically so enzenjani, so thola ukuthi FL ukuthi sithole inumber enkulu kuno Fs kumele le value le ibe above 1, right? Uba above 1 kusho ukuthi numerator kumele ibe inkulu kune denominator. Ukwenza kube inkulu so uthi plus uVL, then ukuthi sithole le value ibe inkulu kuno 1 kumele i denominator ibe incane. Unciphisa kanjani i denominator uthi minus uVs, then we have Fs, right? But when it's moving away, the same formula will apply, but this time so to V is minus VL V plus UVS times Fs, right? But in terms of chela ukuthi ma kwi exam bhala le formula njengoba ino plus or minus ukuze uthole le mark le, because in case we make a mistake and usebenzise lo plus instead of minus, la ufake minus instead of plus, then uzobona ukuthi we lose the mark for even the substitution. Kumbula futhi ukuthi le formula angeke lama sign afane, ma kuno plus phezulu kuzoba minus, ngeke kuno plus plus noma ngeke kuno minus minus. So ma uthola plus phezulu then minus ngaphansi, ma kuthi no minus phezulu kuzoba plus ngaphansi. Don't use plus plus or minus minus, that will actually guide you, right? So mawufuna ukukhumbula nje mhlambe toward ngoba nama possibilities awu2, khuluma khumbula nje ngo top, uzothi on top kusho ukuthi toward up plus, yabo lokho kuzokusiza, then you are knowing ukuthi when it's away then it will be minus at the bottom. Multi top uzokhumbula top, then we have the top of this equation, that is the numerator. Uto umele velo toward, right? Then up it's a plus or more positive wawena, so you know uti maguti is toward is one positive on top, right? So definitely so as in the denominator kuzobo minus. No mama move away kushoguti top will be negative, the bottom will be positive, right? Then you can apply that, and uzothi ukuthi mawenza ukuthi apply le formula, then it will be okay. Then uzonikezwa ngubani speed of sound. The speed of sound in a medium, yakho most of the time is A, right? Speed of sound in a medium, speed of sound. The speed of sound in A is around 340 meters per second. So anything abazokubuza ngayo in terms of this wave, uzothola something around here, 340, normal 333, around 340 speed of sound in air, right? But its speed of sound in water is over around 1,500, somewhere ngalapho, ngoba sound travela fast in a more compact medium, ngoba sithe a pressure wave, ama-particles ona ashayisanayo. So uzobona ukuthi in a liquid ama-particles are very close to each other, so utravela it fast. Then the speed is also faster in a solid as compared to in a liquid. Ngoba in a solid, ama-particles with solid are very close to each other. They are packed, right? So they vibrate in one position. Those vibrations, they actually go faster when particles are touching each other, right? Liquid, ama-particles just a bit relaxed. Kota gas, they are far from each other. To be far from each other, compression ayenzeki kalula. So it takes the speed travels slowly in air as compared to in liquid. It's also slower in a liquid as compared to a solid. So anything ekumele ucalculate izihambisana ne-frequency, izihambisana ne-wavelength, izihambisana ne-period, iya kulama speed lawo. Ungasebenzisa speed semoto ufuna calculator in a frequency, right? Because learners make those kind of mistakes. Basebenzise ini speed semoto lewo 20 meters per second, bafuna ucalculate mhlambe i-frequency noma banigezwe i-wavelength bese kuthiwa bacalculate i-frequency. Ubona umuntu usebenzisa ini i-speed semoto. Imoto ayina frequency, guys, right? So we can now apply this. I said it's not always 340. Now, speed can be affected by weather and so on. Conditions of the weather on that particular day. Makushisa, uzobona ukuthi makushisa sound ihamba fast ngoba ama-particles have what? Higher kinetic energy. So kulula ke ukuthi acompresseke ngoba and a higher kinetic energy. When it's cold, the speed the sound travels slowly, right? But that doesn't matter. So as I said, the value is around 340. Kungaba slightly above or slightly below or 340. Kodwa you must uthola ukuthi calculate a sound wave in air usebenzise speed sa 20. I just know ukuthi you are out ngempela. You are out uma ukuthi uzosebenzisa 20 meters per second, right? So we can have an example here. So a car emits a car that can be emit a sound of frequency, let's say 400 hertz, and travels at a constant speed, at 20 meters per second, right? A stationary listener records the frequency, right? Calculate this frequency, calculate the frequency of the listener. If the speed of sound in air is 340 meters per second, right? So there is a car moving. This car is moving at a speed of 20 meters per second, emitting a frequency, a sound of frequency 400 hertz. Then you have a stationary listener, right? Now they tell you to calculate a reading kwi device yake that will correspond to what is detecting. If the speed of sound in air is 340 240. So into uyenze, take out the data given. So the first thing is funuktola frequency of the listener, that's it. Then sitinga in v, the speed of sound, it's given 340 meters per second, right? Then into scenario vl, they say it's a stationary listener, 0 meters per second. Vs, the speed of the source, that is the car moving at 20 meters per second. Then into shorter Fs, the frequency of the source that's emitted is 400 Hz. Right, so now what we need to do is to calculate. Ngithe mina mawenza i-calculation enza sure ukuthi usebenzisa le formula, faka nje plus or minus, there's no problem. V plus or minus Vs times Fs. So into soyenza is substitution. Kodwa mase senza substitution fanele sifake i sign a correct. So 340. Now what do we need to check again? By the time uthola ukhipha ama information or data given, enza sure ukuthi uyathola whether it is toward or it is away, because they say constant speed of 20, I think angufakanga here, toward a listener, toward a stationary listener. Right, now makuthi toward mawenza is substitution, then uzokhumbula ukuthi sithema ukuthi toward kuzoba phezulu positive, then the listener is stationary 0, then it's 340 minus the car is moving at a speed of 20, then times Fs. The Fs, it is 400, so it's 400 Hz, then tolabani Fl. That's so easily siyakwazi ukuyicalculate ke, so 340 over 340 minus 20, then suthi konke lokho times 400. Now before size sithole answer kumele sibe ne idea ukuthi answer soyithola la kumele ibe greater than 400 ngoba kuhamba toward. Lokhu kuzokusiza in case uhlambe uthole answer engesiyona nje uzoba ne idea ukuthi no answer ifanele ngiyithole kumele ibe greater than 400 ngoba siyazi ukuthi when they are moving toward each other, the frequency of the listener is greater than the frequency of the sound. So ngala sithi equal to 425. Uskipela 425 Hz. Kusho ukuthi the person who's standing next to the road will get a frequency that is 425, and that one is making sense ngoba kuthiwa it's moving toward, and in that case city frequency of the listener is greater than the frequency of the sound. So sebenzisa le formula kanjalo. Right, then you can now have different ways or calculator hlambe bakunike igraph, you can be able to identify kuthiwa an object or a car, so that the same car emits a sound with a certain frequency, right? Emit a car with a certain frequency, ongayazi abasho lutho ngayo, a certain frequency, and moves toward a stationary listener and passes the listener at a constant speed, right? Now let's say constant speed, let's say hlambe abasinike leso speed ile, then kuthiwa calculate the frequency or the speed, calculate the speed of the car. Then into bazokunika yona sekuthiwa calculate the speed of the car, right? Now you are given a graph at the listener records interfananale. Right, let's say lana utola hlambe 800 hertz ngala 740 hertz. Right, so what does it represent? Hlambe kuzothiwa time t. What does time t represent? This time t here, it's when we see by the time the car is coming toward a listener, utola frequency ka 800. Ngoba kuthiwa the car comes toward, passes the listener and move away at the same constant speed. So kusho ukuthi njengoba uthola 800, lo 800 kusho ukuthi that is the frequency of the listener when is moving toward. 740, the frequency of the listener when is moving away. If frequency of the source asiyazi, mase kuthiwa si calculate in the speed of the car. Right, so umbuzo wokuqala uthi t represent what? This t represent isikhathi where the car was at the exact position as the listener at this point. Right, before t then was the car was moving toward. Now asibuke into siyaziyo for now, siyazi ukuthi the frequency of the sound asiyazi. Right, the speed of sound in A 340 as it was given. Right, we use the same thing. Consider the speed of sound as 340 meters per second. The speed of the source of the sound, we don't know it. That's what is the question. But the speed of the listener, we know it is 0 because we are stationary listener. Right, the frequency of the listener, we are given two frequencies. The first one is when it's moving toward, the second one when it's moving away. Manje into fanele uyenzela awuhlukanise lama equations so that kuzokusiza ke uthola ukuthi information uzokwazi ukuyithola yini. Right, so the first thing asebenzise toward. When it's moving toward, so the frequency of the listener is V plus VL over V minus VS times Fs. Masenze substitution. When it's moving toward, kuno 800 la. Speed of the listener 340 plus the listener is stationary, kuno 0 lana V 340 minus VS as VS times Fs, the frequency of the sound asiyazi Fs foot. Right, then singa manipulate le equation. Right, kota siyabona ukuthi sinama unknown out 2, this one and this one. Then as ukuthi by the time it's moving away, when it's moving away, sinani FL is equal to V minus VL, V plus VS times Fs. Masenze substitution. By the time ihamba away, the frequency was 740. So 740, that will be 340 minus 0 over 340 plus Vs times Fs. Sesine equation yesibili. The first equation was this one. Sesine equation yesibili, but with the same equation yesibili still unknown Vs, no bani, no Fs. Right? So into sibona ukuthi sesinama equations are 2, and those two equations they have the same unknown. So kusho ukuthi siya solve simultaneously, solve a simultaneous equation. A simultaneous equation with unknown being Vs and Fs. So sungasebenzisa ama math skills akho ukuthola i-answer. Ngizoqala nale ukuthi toward. Right, now cross multiplication, yonke lento eku-denominator izangala. So we have 800 into 340 minus Vs is equal to leku no numerator kihambisana, so kuno 340 times Fs. Man keep a bracket, so I'll have 800 times 340 igniga 272000 minus 800 Vs is equal to 340 Fs. Right, Then I look at the second equation. So equation 1 way to learn. The second equation ilo maguti move away. When it's moving away again, so kuzobabani 740 into data denominator yonke 340 plus VS, right? Then is equal to again mangi tola logo fs times 340 nigga 340 fs. So mangi keep it bracket, so I'll have 740 times 340 nigga 2516 plus 740 vs is equal to 340 fs, right? So uyabona ke sengi no 340 fs 340 fs kusho ukuthi le value nale kuyalingana. So I can now use my equation tool, right? I can use my math skills and get the answer correct. 340 fs no 340 fs into yoto yalingana, but lo ulingana lo kuna lo ulingana. So kusho kuti these two we can equate them. So 27200 minus 800 vs is equal to 251600 plus 740 vs. Yabona u fs awusekho, so siyakwazi ukusolve for for vs only, right? Ngamletha lo ngala lo nimise ngala, right? So when I do that, I take this 272000 minus, when I transpose this one 251600, so niga 2400 is equal to, then lo uzangala, so it's gonna be 740 plus 800, so niga 1540 vs. Mesen calculator ge u vs man calculate u vx ngizothola ukuthi 20400 divide by 1540 and ngibuya ne speed esithi 13.25 meters per second, right? Sebenza kanjalo. So I can even use this ukuthi ngithole I frequency of the source. Yabo mangibuyela ngala mhlambe ngifuna ukuthi double check kahle, I know ukuthi I frequency of the source izobala phakathi nendawo ngoba u800 means the object is moving toward the listener hear what a sound with a greater frequency. When it's moving away, the sound of the source of the sound did not change, the frequency of the sound did not change, but the listener hears a frequency less than the frequency of the source, that is 740. Kusho ukuthi kuthiwa ngicalculate I frequency of the source, ngizoyithola in between 740 no 800, ngithola in between those two. Njengoba ngithole lokhu kusho ukuthi I can now use any equation ukuthi ngithole bani what is fs. Ngicela ukusebenzisa equation 1 just to get what is it. So vs lana ngifaka u13.25 lo 13.25, so I'll just use the calculator and put everything ngapha 27200 minus sengizothi 800 times OVS 13.25 valley bracket divide sengia divided by 340, right? Kunginika answer it because I need to work it out times ngoba mase ngisebenzisa 800 times 13.25, then I have to divide by 340. Right, now when you get the fs, i-answer fanele siyithole siyazi ukuthi i-answer izoba in between 800 and 740. So when you do that and do the calculation correctly, uzothola ukuthi right 27200, then sibuya nobani 700, so total fs is equal to 768.82, right? Hertz. right? So mangibuyela ngala ku equation uyabona ukuthi 768 ula in between, so it will always give you what those kind of values, right? So yeah, that's it. So yakwazi ke ku apply ke I Doppler effect ku different applications, right? Masikhuluma nge Doppler effect, sikhulume nge application yayo. The Doppler effect by sebenzisa for medicine, by sebenzisa bani Doppler flow meter. Doppler flow meter. Doppler flow meter isiza ukuthi bathole speed sama blood cells emzimbeni, right? Doppler flow meter. So dokotela bawazi ukusebenzisa Doppler flow meter ukuze bakutshele ukuthi medication right, noma ungasebenzisa bani ultrasound machine, right? The ultrasound machine now sebenzisa the same thing. So what happens is that they send a sound with a certain frequency. Now if frequency is fixed, so now machine ola una emitter, like let's say this is a blood cells, these are blood cells, so they send a sound ezo strike bani a blood cell. A blood cell is not stationary, iyanyakaza. Njengoba inyakaza there is a relative motion, kusho ukuthi le sound iya reflector. When it reflect is collected here, so bazothola ke leyo difference and bazo calculate ini speed say blood cell. That is a Doppler flow meter. For ultrasound machine is the same thing, but makwi reflector, a reflector into izofika ne shape yengane saseswini, right? Then they can tell, oh, this is a boy, it's a girl, something like that. Goba ifika in a reflection in a shape yale obstacle itolile, right? So that is the use of application Doppler effect, right? The last part application Doppler effect, so khuluma nge Doppler effect with light. Doppler effect with light. Doppler effect with light, with light we can also observe Doppler effect. The inkinga ukuthi the speed of light is too high. The speed of light ubani 3 times 10 to the power 8 meters per second. Now in terms of light, light sibuka ngani ngama colors. Sakhumbula O, Roy, G, beef. Red, orange, yellow, green, blue, indigo and violet. So into says yokuthi as you move from red to violet, that is increasing frequency. The color red has lower frequency than orange. It has a lower frequency than blue. It has lower frequency than violet. But red une longer wavelength than the rest kuma colors. So into sobona ukuthi when there is a Doppler effect, color ingashinja ke. Now depend ukuthi ishinja toward higher frequency noma toward lower frequencies. Lento soyibiza ngama shift. Now we'll have two types of shift, okodwa sothi red shift, okunye sokubiza ngani nge blue shift, right? Comparison lawo to now red shift represent lower frequencies, blue shift represent higher frequencies. Now in that case uzobona ukuthi masino red shift kusho ukuthi we observe, the observer sees what an object that is producing a frequency that is higher than the frequency of the light. Let's say sino yellow, for example, right? Then if a yellow light moves toward a person, angisiyazi ukuthi makuhamba toward sithola ukuthi higher frequency. So yellow une lower frequency than blue. Kusho ukuthi the observer uzobona bani? Uzobona blue. So the yellow color will change in blue. Why singa observe lokuzani Doppler effect with light? Ingoba lesi speedless kumele ukuthi the object that is moving has to move with speed esila closer to 3 times 10 to the power 8. Angazi ukuthi siyakwazi ukuthola into izohamba ngaleso speed leso. So when we observe into a higher frequency, the object is moving toward it, right? And we call it what? A blue shift. So there's a blue shift if they are moving toward. Ngoba blue, it's higher frequency. A red shift, it's when we move toward the lower frequencies. That is the red shift. And scientists could say that the universe is expanding simply because of the red shift. The red shift is when they observe other stars in the planet, it gives what in a red shift. Actually, it's going to red because it shifts toward red. So ngabo yellow utola bani orange. So not exactly yellow upenduke red, but as long as it shifts a bit. No yellow, it's moving toward the green. That is the direction toward the blue. So you have what? A greater frequency. So scientists use the redshift to conclude that the universe is expanding, right? Because maune balloon, for example, nali balloon, then just draw 2 points on that balloon. You can measure sambozuti 1 centimeter between the two. Try to blow the balloon. Uzobono guti maune balloon the same kuluge manje. There is a distance, a greater distance between the 2 points. Now mbuzo uti. Did the point move anyway? Did this point move? The point toward the right, the other one on the left. No. But it's the universe where they are that has expanded. So umuntu, if this is the planet, umuntu planet Earth and this another star, the distance between the two is increasing. How do you find that? Because of the blue shift. Kia shifter toward the blue. Then they conclude that the universe is expanding, right? So that is for Doppler effect and Gyatembage unisizagele. And this is a topic where you must make sure go to your collector wonke la mamaki, right? Ayasibongeke for namhlanje grade 12. So hlangana futhi next week. Same place, same time.
Ningakhohlwa ukuthi nisengathokozela ezinye izifundo eziyisithupha kanye nezengeziwe i-learner wellness, i-career guidance kanye ne-advanced program. Hlanganyela nathi kwizifundo ezi-online ku-068 151 1072 noma ku-GoDigi@godigitalsa.today. Siyabonga.